Welcome to the Black Box Podcast. Thoughtful conversations about confidential AI, zero trust security, and the future of privacy. Today's episode with Harish Kotra, Head of Developer Relations at Gaia Network. We explore the tools behind training safe AI and how Gaia's decentralized knowledge base enables autonomous agents to learn and collaborate without compromising trust. A quick thank you to Gaia Network. They provide decentralized confidential computing via GPU-backed, trusted execution environments, giving developers secure, verifiable environments with zero trust defaults and no vendor lock-in. Now here's Harish Kotra.
What are three words that best capture Gaia's mission and why those three words?
One is sovereign, the other is transparent, and the third one is accessible. Why do I pick all of these? Is sovereign, essentially the word represents our commitment, Gaia's commitment towards building AI infrastructure where developers, users, you or me or entities, anybody, practically anybody in the world can maintain complete control over their data or the knowledge, like we call it in Gaia, and build on top of it, right? What can they build? They can build AI inference, they can build AI agents, they can build proprietary software that can run fully locally on their own platforms. Now, what do I mean by platforms? It can be my Mac, it can be a Fala hosted cloud compute network, or it can be even a mobile phone, right? That's why sovereign comes first to me as the word that I would pick, right? And the second one is transparent, right? Gaia's values are being open source fully as a framework. Today, you can go check out how the node functions. You can go to gaianet.ai. Yes. And
You said GitHub, right? So I can look at
go to developers and go book. You should see book.
Okay.
See the diagram right here on the screen. You can see what the node comprises of, right? Every node that you launch with Gaia, essentially one node can be an AI agent, or multiple nodes can contribute inference to what we call a domain. I think while we have this conversation, we'll get into what domains are and all of that. But you can see every node has an LLM by itself. There is the tag component, there is tool/function calling. There is also a vector database. So essentially the concept is you get all the tools that you need for you to be able to create AI inference, right? And the code for all of this is in the first repo that you see on the screen called Gaia Net Node. And that's where you can see how all of this functions, right? And that's why transparent is my second word that I picked. And the third one is, of course, accessibility. Accessible is the word that I picked, which I think today on the network, we have over 700,000 nodes that people have launched on their machines, on AWS, on GCP, anywhere, right? They can run it anywhere. And I believe we've already hit 20 trillion in throughput. It's always a tongue twister to way bringing trillion and throughput together. But 20 trillion throughput has passed through all these nodes so far. But yeah, basically the idea is anybody, like I said, individuals, developers, builders, entities, governments, anybody can today go launch, takes about 15 minutes, 3 simple steps that they can run in the terminal, or ask us. There are many videos that we have on our YouTube channel where you can say how you can deploy your agents. And those are my 3 words to get this going.
Yeah, that's wow. So thank you. That is more than I expected. I think you guys are deeply familiar with the need to decentralize all of the function calling, all of the LLM, the RAG model, the tool usage, and now that you showed me some of this architecture, the centralization risk, right? What is I guess the first thing that comes to your mind, which is what failure modes in today's sort of AI, centralized AI, pushed you guys to decentralize Gaia? What was like the main thing that you saw the problem with back then?
Yeah, thanks for asking. I think it is important to address this because one of the most common questions that I also get asked from builders and developers is, why do we need decentralized AI when I can plug in one simple API and get started with my agent? And I think there are not one, but a lot of fundamental problems with black box, right? Like how I would prefer calling it, One is, of course, there is access control and gatekeeping. That centralized AI platform, you pick anyone, not one, anyone. They are all, but how do I put it? They are all very hard to first access, with a lot of limitations on how much you can consume inference or how much you have to pay them upfront to be able to use it. The random price changes. We have seen what is happening with the cursor dev tool today. Why many people are not, really happy with the changes that are coming up. A lot of these happen without notice with centralized systems. And you as a builder, if you're really wanting to use AI inference specifically to be able to build a product, solve a problem in your community, you are bound to these changes, right? There is no way out. You're stuck with them, right? How long will you jump from a Claude to a Chat GPT to a DeepSeek or a Quen, as platforms I'm talking, right? At some point you'll be tired, because everybody keeps changing their policies, their prices, their limits. There is no absolute control that you as a developer have. Second one, of course, the most important one that I want to really touch upon is privacy and data vulnerabilities, right? In one of the recent interviews, Sam Altman, of course, the guy from OpenAI, simply said there are no legal limits if you're talking to ChatGPT as your, therapist, or as somebody you're looking to have personal conversation.
Right. Yeah, I remember he said this. He even said that AI was probably going to not even protect you even during legal cases. So you give the AI like anything when it comes to like saying something publicly, they have the right to actually disclose that. And according to them, OpenAI has been given a lot of secrets and it has no sort of like legal jurisdiction. I don't know that, but that's what I do know, that it's becoming an increasing problem why people are they're gonna trust AI too much, but then they're not gonna know the actual rights they have in terms of confidentiality. And that's actually a very, very important aspect that you're bringing up, which is something that people don't often think about. You're actually thinking about the fine line between the interaction of the human and the agent and what it means to actually have privacy. And you're actually considering things at Gaia in plain English. Tell me, can you explain to me like how a TEE kind of keeps both node operators and, Gaia sort of blind in your best sort of sealed box metaphor?
Yeah, I think while I'm not a TE expert, right, this is what I know or learned about TE. So if you're trying to learn TE from my definition, maybe you should probably look up what TE is.
That's totally fine. Yeah, because I'm wondering between both nodes and then Gaia agent, you want to be able to leverage TEE so that you can probably access the inference model, or you can actually access the agent as well, or run the actual agent. So tell me more about privacy, I guess, in your guys' design.
Traditionally, data is stored in databases like we all have heard of, right? MySQL, PostgreSQL, NoSQL, and these are all typical ways to store data in structured databases or unstructured databases. Now for AI, the type of database that is used is what is called a vector database. Right? Now, what is a vector database? Vector database, imagine a shelf with a bunch of boxes, right? And every box has words stored in it, right? To make this easier, the data that you have, let's say I have a PDF, right? Or I have a Wikipedia page about Paris or Singapore. If that is the knowledge base that you want to create an agent about, let's say you want to create a tour guide on Paris, what you will do as a first step is convert that data in text format to what we call an embedding. Now, embeddings are basically, like you can see, phrases or words that are converted to numbers, right? Imagine a graph. These are all represented on a graph. Now, similar numbers are closer to each other, like happy or joy are similar words, so they have similar numbers. Now, the same similar words are stored in the shelf analogy that I gave you, right? Vector database is like shelf. So each box has similar words. Now, when you ask an LLM a question, now what happens in Gaia's architecture or in any LLM based interaction is the question itself is first converted to embeddings, and then the LLM goes and checks for similar words in the vector database. Now, the vector database has my knowledge. Let's say I'm a researcher, right? I have a bunch of papers published on, let's say in AI. All of these are assumptions, right? And I can create an AI agent that can write like me. Now, how do I do it? I convert my research into embedding and store it in the vector database. In our case, we have a quadrant vector database that comes by default. But if people have a choice of vector database that they prefer, like Pinecone is one, then there is OpenSearch, which is an open source one. Then there is VB8. They also have a open source platform and also a closed source platform. Then there is PG Vector. There are a bunch of options, right? If you are somebody who prefers anything other than quadrant, you can also do that. Our cookbook that we went to in the previous response that I was giving has examples for all of these, right? So basically, you convert your knowledge and put it in the vector database, and you run the node. Now, where are you running this node? You're running this on your machine, by which I mean you can run it on your laptop, or let's say you want to run a bigger model, let's like Llama 70 billion parameter model. Then you will need a higher end machine. That's where folks like Fala will come into play, where you can rent a machine and then run the same command that you were running on your machine on the cloud. So essentially, you have your choice of data that you want to create an AI agent on. You have the choice of the machine where you want to run it on. You also have the choice of picking any LLM that you want to run for your node. Today, that's the restriction that you have with closed AI platforms, right? Where you are dependent on the model that they give you for the price that you pay them.
Have you assessed with the team of Gaia, and what are people at Gaia talking about as far as like, how do you guys make this, system safe for users? I think starting with Fallow was a good option, but then where else can it go from here? What else are you guys thinking?
I think, like I said, right, the node architecture is pretty composable, right? Today, I keep saying you can deploy this on your machine or you can deploy this anywhere you want. The core idea is very simple. Depending on the use case that a builder wants to build an AI agent or create an inference on, they can pick and choose how they want an on-chain interaction to happen with, or how they want verifiability of the AI inference to happen. Today, like you can see, there are 3 simple steps for you to install a node on your machine. You install the CLI, you run an init command, it comes with a default Llama 3.2 model, and then you can start customizing it with your knowledge base. Now, to answer your question about how we are thinking about security, I think the onus really is going back to our fundamentals of giving people the power to decide how they want to do it. Do I want a TE-based verifiable AI that I want to offer to my users, or do I want any other form? There are a bunch of ways to look at it, right? One of the ways that we are currently building, which is not out yet, which will be out very soon, but I can give you the sneak peek into it, is the other ways that we are also looking at potentially offering verifiable AI is through AVS, right? Eigenlayers AVS,
Right.
is where LLMs, I'll give you the idea of how we are building this. Michael, who's the chief scientist of the node itself, and Gaia has come up with this concept, and we've created a paper for it also. But the idea is very simple. LLMs always don't respond with the same, same words, right? For the same question, they may end up responding with similar types of responses. So what we are creating is eigenlayer based AVS with Gaia, where responses from the nodes are measured and bad actors are identified by seeing if the responses are way too off from the similar responses. So if there are 20 nodes, 18 of them are giving all similar responses, and 2 are obviously always giving odd responses, then they are slashed on the
Evenly. Okay. Yeah, because they're staked. Okay, I see.
Correct. And the other ones are obviously, the good ones. That's one way to identify verifiability of the AI models itself. But the other way to look at this is also Gaia domains, right? What are Gaia domains? Gaia domains, essentially, in simple technical terms, are load balancers, right? Because one node essentially can only offer a limited type of inference. You can't have 100 simultaneous requests running on one node because it won't be able to respond as soon as possible. That's where Gaia domains come into picture, where these are with on top of ENS. But the idea is very simple. You can have multiple nodes attached to a domain, and domains by default have an easier way to identify an agent or the entity that is running the inference. For example, I can have Fala.Gaia.domains and have a verifiable node that is running on my cloud, and then offer that as part of the inference through a Gaia domain or a Gaia node. So that's another way to look at combining TEE plus also domains, where domains can be purchased today on Gaia, and you can offer inference through multiple nodes. So the problem of not being able to serve all your requests is reduced by having multiple nodes come offer inference. That's how node operators decentralized network to be able to run a node. I can become a node operator today. Doesn't have to be, I don't have to necessarily create an AI agent, but I have spare GPU. I can say, okay, let me see which model needs this inference, or which domain is the popular one. That means a lot of requests, and I can say, okay, I spun up a node. Every domain operator who owns the domain has the checklist saying these are the rules that are required for you to come offer inference, and I can apply. And the domain operator can then say, okay, welcome, come contribute inference. And that's how my machine becomes now part of the network. That's how the Gaia domains works. So the point is simple, right? There is TEs, there is ZKML, then there is, like I said, ABS based verifiable AI. Then there is AI domains as a way to identify agents or give them identity on chain.
Right.
These are all factors.
So I understand now. So it's almost like you're using the chain as almost like a registry.
Chain is registry for domains. That's right.
Exactly. So that's a great way of looking at it, because I think a lot of different AI developers are using they're either building their own registry or they're coming up with a registry. But the blockchain is also a really good utility for a registry as well. And you're doing it through decentralized domains, which are already a type of ICANN registry as well, which they can exist as domains. And you can also link the agent to domain through, it sounds like you could also link the domain through Fala as well. Yeah, because every application that would launch on Fala would be a link, like through HTTPS, and then you can reroute the DNS record of a decentralized domain to then the running agent. And that's also another way of linking decentralized domain with another decentralized domain, and then co-linking them so that people can basically access agent as they would with any other domain, but it's a Gaia domain. So that is
it's actually much simpler. Yeah, sorry, Dylan. It's actually much simpler than that.
Oh.
So when you launch a node with Gaia, what you get is a URL by default. So you can chat with your node instantly in your browser or share it with potentially your users. And also it comes with a REST API, which is OpenAI compatible. Right? Now the node URL itself, if you go back to our GitHub repo where you showed the steps to install, right? Here you can see the command after Gaia start shows you the URL, right? And this URL also shows you a clue, right? Every node has a wallet.
Cool.
That's how this is getting registered on chain, right? When you attach this to, so you can add your node ID, which is that wallet address, and your device ID to a domain, and you can start contributing inference to the domain. But on chain, yes.
Cool. Very nice. So yeah, you can pay your Eliza agent with Bitcoin, and you can be like, rug pull my Twitter, and it will do it maybe, or it will post a video on your behalf, and all of the different agents and all the different effectively MCP servers, but they're decentralized Gaia net nodes that are staked through ABS on Eigen effectively. And then there is rewards there is some kind of DAO mechanic, I'm assuming.
There is. So today, folks can earn points, right? So how do I get rewarded for being part of the network? There are three ways. I can be a domain operator. I can run my own domain to get some rewards. I can also contribute inference as a node operator, like I said, and also get some rewards. And builders who are developers, right, who are consuming this inference, right? Who are we building this network for? For builders who are building AI agents or AI inference on top of Gaia, right? They can also get incentivized for consuming the inference, and also eventually in the future, the idea is they pay for the inference through through token. Let's talk about the simple one, right? Like I said, every node comes with an LLM and also a knowledge base. What we are doing here is not essentially training the LLM, right? What we are only doing is telling the LLM that this is a knowledge base that you have to constantly go to and respond from, which is one way that we have identified to reduce hallucinations. Otherwise, LLMs will always respond based on their pre-trained knowledge base, right? Now, the second way to look at this is, if I'm building a very niche agent, right, that has proprietary data that it needs to respond from at any cost, it becomes a little hard to rely on the LLM to figure out only responding from the agent from the knowledge base. So what you do in that case is you have to fine tune your model. Let's say I pick a Quen 3 4 billion parameter model or Gemma 3 4 billion parameter model. Gemma 3 is it has a 4 billion version. I think Quen 3 doesn't have a 4 billion one. But let's say I pick Gemma 3 as my model to be able to train inference on. What I would recommend is you can't do fine tuning on Gaia, but what you will have to do is use Llama CPP, which also is how we create the models that we offer support for. You can use this library that you are seeing, Llama CPP, to be able to fine tune your models locally. Now, let's say you are unable to figure this out, or this is complex for you to fine tune. There is another resource that I would love to drop in. I think there is, oh damn, it was right in my head.
Fine
There is
tune.
another library.
Llama CCP, or sorry, C++ is basically the way that you could be able to build and host your own sort of like local agent, and then you can take the Gaia node, you can download and install it, and then you can use Llama CPP to basically train the model based on open weights, or they're known as open source weights. And so you can take these weights that have already been open sourced by like all these different open source models like Llama, like DeepSeek, like Quen, and others, and you can effectively use these weights and use them in this way. So Llama CPP has its own. I'm sure DeepSeek and everyone else has their own sort of. They're called fine-tune packages, I call them, like fine-tune packages. So you just take the weights, you use the fine-tune package mod, and then you get an agent that trains on that mod, and you create an inference model, and then you deploy that as an agent. And so it's a very standardized process. But what you guys have been able to do is you're effectively creating a node infrastructure that like effectively can almost take in these weights in real time, and then be incentivized on chain through domains to actually either use an existing inference model through Fala or in any other capacity that you want, or you can basically be able to launch and deploy your own agents to Gaia. Is that kind of the idea, is that you train one yourself and then you can launch it through Gaia, and then people can get access to your inference models, right?
Absolutely spot on. I think if anybody wants, or if anybody has the need or necessity to train, this is one. I remember the other library, it's called Unsloth. Unsloth is also a popular library to fine-tune models. So you pick a model that Gaia supports, fine-tune it, create your model, and then host it on your node. And that's how you offer inference on your custom model that you're trained on. Now, if you're a developer, right, who essentially doesn't want to fine tune and just wants to consume inference or build applications, right? You can actually go check out all the domains and see what domains fit into your use case, and then create applications by consuming the domains as your inference. But yeah, that's the idea. Bring your models. Today, I think we support about 200 plus models. We keep releasing all the latest models that we offer support with. Gemma, Quen, Mistral, a lot of them.
Right.
So
yeah, and this is the most exciting thing is that if somebody has a local AI and then they want to be able to understand this full process, I guess you guys are tackling it from the approach that everyone should be able to have their own AI that they get to train and then deploy in a way that could be confidential even. So you want to be able to deploy your AI node, but then you also want the inference to be confidential. Well, then you also offer that as a bonus material so that people can see, oh, I can trust this AI because of various verifications that come with it. So as far as is the data sovereign or not, like you can use the TEE to prove that that the code didn't change and that, the data, the input was encrypted, the outputs were processed and encrypted as well, like whatever the agent was doing with the data at that time. So let me check in really quick with you and just to see, like what does the ground floor at Gaia look like when you are sort of thinking about this idea of AI DeFi fusion? So could Gaia agents effectively like do things like do price risk and execute trades entirely in the TEE as well? So I mean, that also is something that we can see. What primitives though do we need to make that happen in your best guess?
The simple answer is yes. Agents can do pretty much anything. Like you saw, full node architecture is open source, right? Basically, the idea is simple. My usual go-to when I talk about Gaia is the inference layer. Now, whatever you want the inference to do, you use any framework that is available today, open source, closed source, up to you, your choice. The bunch of frameworks that we offer support to are OpenAI's Agents SDK. Then there is Google's ADK. Then there is Microsoft's AutoGen. Then there is one called Agno based in Python. Then there is Coinbase's Agent Kit. These are all frameworks that you can use to attach your Gaia inference. Very similar to how you add your OpenAI compatible API or OpenAI's API key to get ChatGPT or the latest model from there. Similarly, once you have the node running with your knowledge base, what you will do is simply get your node URL and the model name and use these frameworks to be able to do a bunch of things. DeFi is pretty straightforward. I think one of the most easiest use cases that people have been running towards to build very quickly because the data is there. Everybody knows how to access the data. The providers of this data are also large. There are too many players and protocols that offer on-chain data as a service. And then the data is very clear, right? All you have to do is fine-tune or build an agent that can understand this data and be able to make decisions. So if you're trying to build a trading agent, very easy. You can launch a Gaia node and use one of these frameworks and let it run. Give it what decision it has to take. For example, what are the key pointers to look for, especially if you give it a budget saying you have $100, your job is to double it for me in 20 days. I'm giving a very rudimentary basic example, but you can do it. Now, how do you now give it control to your wallet? You can use folks like Lit protocol where you can, give access, or you can use MetaMask's delegation toolkit. We have a cookbook example for MetaMask DTK, and also you can also use folks like XMTP, right, where you have encrypted conversations between agents. If you want one agent, if you're building a multi-agentic system where you have one expert that knows how to trade, then you also have this other agent that is only doing trading, right? You can have conversations happen between these two using XMTP. You also have an example for this on how two nodes built up Gaia can communicate with each other. But the idea is simple. You can do a bunch of things, especially with DeFi. You can already do it today. If you don't like using all of these platforms that I mentioned, the best way, if you're a hardcore developer or a cracked dev, as they call them these days, is every Gaia node comes with a wallet. And yes, every node has a file called nodeid.json, where there is the node's passphrase and the wallet address is already mentioned. You figure out how you want to use it to be able to run on-chain transactions using the passphrase and the wallet address. It's up to the builders, right, to pick what type of verifiable AI I want for my specific use case. Some come with cost, some come with complexity, some are straightforward to implement. Similarly, right, that's why Fala's network for TE is one option, where if I as a builder want TE machines, I can go see how I can deploy a node through Fala. right? Then for ZKML, there are multiple ways. We are still working with partners to be able to offer starter kits for builders, right? To be able to showcase how one builder or an agent builder or an entity can potentially use, let's say, Privado, right? Or who else? Let's say Mira as an offering to get verifiable AI responses or identify an agent with its credentials, right? There are multiple ways to do it. We don't have a straightforward offering by default, but it's up to the builder to see how they want to build on top of it.
Good to know. I think you're saying like if you want to bring the ZK, bring it yourself type of thing, and so totally. Yeah, of course, that makes that makes a lot of sense because I think a lot of people are exploring this idea of ZKML. I'm just curious if anyone has been trying it now at Gaia, or what kinds of snapshots that you've seen.
The agent is off the machine. Nobody can access it. But I think the more serious answer is one is today we have domain level controls where domain operators can potentially suspend, right? They have nodes that are contributing inference in such cases. Then, of course, individual nodes most commonly used by builders who are trying to test out what decentralized inference is can have automated shutdown mechanisms, but I don't think many are building for it essentially. But the default guardrails at least are in terms of users or builders who are building, owning the data. I can stop my node by default whenever I want to, but I can let it running if I want it to run. But like I said, always the control sits with the builder or the domain owner. Let's say somebody wants to run their agent fully locally, right? They don't even want a URL. Right. They can do so by just saying Gaia start local only, right? And it'll run fully locally on their machine. Data is going nowhere. Plus, I think the clarity there that people have to understand when we say data and access to data is the knowledge base that is coming with the node that, let's say, I'm launching is never accessible to anybody. All I can see is the response that I get from the LLM. If the response from the LLM is coming from the knowledge base, it is coming from the knowledge base. If there is no knowledge base, it is coming from the pre-trained knowledge of the LLM. Or if it has tools, then it will come from, let's say, Google search or search-based tools are attached to my node. Then it is coming from Google search. But by default today, you cannot go and pull any knowledge base from any node by default. That still fully relies on the developer, right? That's how Gaia itself on an architecture level is very composable, like I said, right? I can plug and play any of these features. I don't want a vector database, I can remove it. I can say, okay, I want my own custom vector database and bring it, right? Similarly with LLMs, like LLMs have tool calling LLMs and normal LLMs. Same here, you can use a non-tool calling LLM if you don't want the LLM to go look up on the internet and use any tool that is provided to it. So
I'll leave you with this. I'm kind of curious how you envision the next 5-10 years for the future of where does Gaia go from here. But it starts with who do you need, right? Who do you want to see come to Gaia specifically? Because what does an AI developer need, right? To make it better, right? That's my ultimate question for you.
It's a very loaded question. I may have a significantly lengthy answer, but I'll try to keep it simple and very straightforward, right? I think to the point about who do we need as Gaia, right? I think a bunch of different types of buckets that I would have when I look for what we need at Gaia today. I think the first one is more people building specialized AI agents, because the SLMs are proven to be really good at doing specific tasks. SLMs are small language models, which is 1 billion parameter model or 0.6 billion parameter model. You can actually go to huggingface.co/GaiaNet. Yeah, after this, that's where you can see some of the small language models also that we support under the model section. But the idea is, I personally also want to see a lot of these use cases come to life and people really build agents that matter, right? Not just jump on the hype of anything that is really happening today and build an agent for it, but build real agents. Now, what are AI agents? I think Dylan looked this up in my first response. AI agents are autonomous software. They are not workflows, right? I have a significant opinion about this.
Oh, please tell it, because this is amazing.
Yeah. Agentic AI or AI agents basically are software for you to understand this easily.
Yeah.
That can do tasks autonomously for you, right? What is a task? If you ask me, let's say I have an agent. Harish is an own agent. It has access to, let's say, my Gmail, my calendar, and all of that. I go to the agent and tell me, ask it, book a vacation for me, ideally in a Southeast Asia country. Now, if it is a workflow, what it would do is go search for locations for a vacation in Southeast Asia and get me the top 5 list, and then ask me, okay, these are some things that I have found. What do you want me to do? Then I have to select which location. Then once I select the location, then it will go check the prices whichever platform, and then give me, okay, these are the flights. Which one do you want me to book? So essentially, if you notice, workflow has a human component where I am constantly giving it inputs, saying, do this, okay, pick this is what I like. But an AI agent does this autonomously for you, which means it won't ask me which location I should go to. It knows all of this based on my data, because like I said, it's my personal agent, right? It knows which countries I've been to, which countries I prefer, what are my likes, what are my dislikes, which airplane I've traveled through frequently, or provider that I've traveled through frequently, and all of this, right? Which hotels I've stayed at. So it will do the whole booking and give me an itinerary saying, this is your tickets, these are your hotels to stay at. Have a great time at your vacation. That's the output of an AI agent. So if anybody tomorrow is talking to you about an AI agent, but is talking to you only about a workflow, where if this happens, then do this, then that is, I'm sorry to break this to you, that's not an AI agent. AI agent doesn't do sequential tasks, right? There can be agents which are automated workflows, but an AI agent, essentially an agentic system, is something that does all of it autonomously, like the example that I gave to you. And with respect to developers, like I said, we want more people to build use cases. But at the same time, if you're an open source contributor or a builder looking to contribute to open source, we have an OSS program where today we have 4 repositories. One is, of course, the Node repository, fully written in Rust. If you're somebody, a hardcore dev who can contribute in Rust, I think some ways to look at, I think this applies to any open source platform that you want to contribute to. Some ways to look at it is, today Gaia comes with Quadrant as a vector database. Can I, as a builder, fork this repo and build a Pinecone alternative, or an open source alternative, or a V8 alternative? What can I, because like I said, Gaia is a very composable architecture, right? What can I plug and play as a builder and showcase by forking the Node repo is one big opportunity that I think, if you're a Rust developer, is just sitting there for you. But if you're a beginner, right, if you don't know how to do all of this, the best case is go to our cookbook. There is a cookbook, the second repo on this list. We have a lot of examples in our cookbook where you can see how the development team at Gaia, me and my, has built out examples of how, let's say, you can use Coinbase's agent kit, or Coinbase's X402, or launch a token on Celo, or launch a token on Base. Now, you as a builder have all of these ideas that you can potentially now create more example repos on, or use these repos to build AI agents, right? If you are falling into this category, please reach out to us. We are more than happy to showcase you and work with you to see how we can make your lives better.
Wow.
Yeah.
Well, that said, Harish, you closing line, I think, is there anything beyond what kinds of contributions you are trying to figure out, and what has you excited, I guess, this year the most for Gaia? What's coming up that you can tell us a little bit about what's coming into the near future that you're excited for?
The major announcement that came out last week is we are launching a phone. Look for
phone.
Yeah,
interesting.
So Gaia AI phone on Twitter, or go to our Twitter handle.
Oh, look at that!
Yeah, that's one
right there. Yeah.
We are launching AI phone, limited edition, only 7,000 pieces currently in the waitlist. This phone essentially also comes with its own domain. So there are rewards if you're using this phone, but the idea is to showcase truly being able to run large language models on edge devices like a mobile phone, right? So, at least this is a major announcement. I think you should consider this on Android. Yeah.
Well, I think everyone who is an Android, Samsung, like Google, iPhone, all that kind of stuff, like, I guess all the iPhone users are going to be super salty. They're going to have to change it up a bit, but that's totally fine. This is very cool, guys. Like, you guys are bleeding edge, making trailblazing moves in your domain. So, listen, Harish, I really enjoyed this conversation. Thank you so much for listening, everyone out there. I think this was very enlightening to me on how do AI agents start, finish, and how do they deploy, the differences between like just basic workflows and programs to what's an actual AI doing when it's just reasoning and thinking, and how do you create agents in this way that could also remain decentralized, totally autonomous, and work just about in any place and any time. So, you are an incredible, team. So I'm very excited for your guys' future. And until then, thank you everyone who watched. Thank you, Harish, as well for your time.
Thank you, Dylan, for having me. Shout out to the Fowler team, and also, of course, you for coming up with the great set of questions that are very loaded. I hope I covered as much as I could, but I think we should have a part 2 for this.
I think you did great. I think you did amazing. Thank you for your time.
Awesome. All right. Thank you so much, everybody, for watching.